All right, now we have a problem here that is all about scalar and vector. For this one, you're just asked to draw an arrow and label it R to signify that that is your resultant velocity of the aircraft. Now, before, even though it's just a drawing, right? Before you draw anything else, you need to identify first properly where would be the aircraft be going after all of the directions and all of this velocities involved in it. So the first thing that you need to do is look into the directions. So the arrows on the bottom with the 28 meter per second value is actually going northwest, right? And the 95 one is going horizontally to the left or westwards, basically. Now, most or some of the students would try to immediately draw a resultant around this area, which is completely wrong because again, yes, the aircraft is going to the west, but the other velocity is pointed towards the northwest, so it should not be going to the south, right? So in order for us to correctly draw the direction, you need to extend this line here, okay? And most likely, this will now be your resultant. Okay, now, as we go on to the next question, it says here, determine the magnitude of the resultant velocity. Okay, now, I copied the image earlier so that we can actually identify properly how are we going to identify the velocity, the resultant velocity's magnitude. So what we're going to do is we need to extend this again. Okay, redraw the line. Okay, all right. Notice that the triangle that we have right now is not a right triangle. Therefore, we cannot use immediately the Pythagoras to find out the hypotenuse of the triangle. But what we can do, given that what we have, right? We have we know this side, right? We know this side, this one. Let's call it B. We know this, right? We know this angle, basically, right? We can identify that angle. Since it's a straight line, that's 180 minus 65. 180 minus 65, that gives you 115. So this is 115. Okay? So we have all of those values. What can we use immediately, right? So that we can solve directly R. I think we can use what we call as the cosine law, right? So going back here, so if we have all of those values, then we can say cosine law, right, is equals to R equals to A squared plus B squared minus 2AB dot cosine, let's just say it's called theta. Okay? All right. Then square root all of it. And of course, copy on the value, you'll have here 28. 28 squared plus 95 squared equals to 2. 28 multiplied by 95 dot cosine 115. Then square root all of it. Let's just solve it real quick. Square root of 28. 28 squared plus 95 squared. If you're doing it directly in your calculator, I would suggest you try to put the parenthesis so it's not confusing. Then minus 2 times 28 times 95 multiplied by cosine 115. Oh, wait. One more. All right, there you go. Then I got an answer of 109 meter per second. That's how you answer in finding resultant velocity.